This valve causes a pressure drop. The high-pressure liquid becomes a low-pressure liquid. This is like letting air slowly out of a balloon. The air in the balloon is still under high pressure, but the air that gets through expands and its pressure drops. In the same way, refrigerant that passes through the expansion valve expands, and its pressure drops.
Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, hello everyone. Thank you for joining Did You Know? The ESCO HVAC Show. My name is Clifton Beck. I'm the host of the show, and I'm so glad that you've joined us today. So today, we have our very own Howard Weiss, Executive Vice President of ESCO. Hello, Howard.
Hello, Clifton. Glad to be
Joining
here.
us. Howard is actually here with us every week. You may not know it. Howard is in the background on every show, keeping an eye on the chats, watching out for the love me long time messages that come through, which we do get sometimes, but trying to make sure that we have the ability to interact with you as much as you want to interact. So we highly encourage you to interact with us today. Send some messages. Let us know where you're chiming in from, and if you have any questions along the way, so we can help dive deeper into some of the questions that you have. So what are we diving into today? Wow, there's a lot to talk about in the world of heat pumps, isn't there? You know, we've been diving into cold climate technologies and resources and rebates, and there's a lot of education in the industry right now. Our very own Jason and Eugene are down at the HVAC School Symposium down in Florida. We've got the AHR Expo coming up here in a couple weeks. We've got a Johnstone Expo in like 4 weeks or so. We got our own expo, our HVACR Education Conference in Las Vegas, March 20th through the 22nd. Love to have you there with us. So a lot of things going on right now and a lot of things to talk about. So let's dive right into it. Today we're going to talk about heat pumps. There's a lot of questions that have came through. I've had emails, I've had phone calls about the differences in heat pump technology and why some heat pumps work well in some zones, others, and how have we changed technology over time. And we really have changed technology very significantly. And we are selling a lot more cold climate heat pumps. Here's where the concern comes in. The most questions that I have gotten have been on ducted cold climate heat pump technology. And the biggest concern is that we don't have a lot of options for ducted systems. We have all of these cold climate ductless systems, single zone, multi-zone, but not a lot of them in the ducted. We actually do. And that's what we want to talk about today, is being able to have the proper resources and the proper training to look at the variety of heat pumps to see how well they perform. When we talk about comparing items, when we get into the things of purchases that we make on a daily basis, we have a lot of comparison tools, don't we? Like if we were looking for a printer, we can hop on things like Amazon and we can, compare different products, different models, and get some ratings on how well those perform. We've got a variety of resources, consumer resources that we can look at things. But what about our HVAC? What do we have to compare heating products in our industry? Because if we're an educator and we're looking for the equipment that we're going to need in our training facilities, if we are a contractor, a technician, and we're looking for equipment that's going to work in our application, if we're a distributor that's looking for brands of products to carry, how do we know how well each one performs? Well, that's what we're going to get into. And we're so glad that you're here. We want to make sure that you can continue on all these educational paths with us. So you get a chance, hop on our YouTube channel. Some of you are joining us from YouTube today. And make sure to subscribe and turn on notifications so you can be here with us live every week. So what has happened in heat pumps? If we look back at our heat pumps, the ones that give heat pumps kind of a bad rap back in the 1970s, 1980s, we're talking about technology that utilized a lot of reciprocating compressors, a lot of permanent split capacitor indoor fan motors, outdoor fan motors. We would use fixed orifice pistons, flow raters, and maybe an expansion valve sometimes. But the technology was very basic. We basically took an air conditioner, added a reversing valve and a defrost timer, and boom, off we go. And we got as much as we could out of it. Wasn't really a lot. Wasn't the amount of heat that we actually needed. So as we have progressed through time, we have increased the technology going into our systems. If we looked at those reciprocating compressors, let me back up real quick. So I want you to pay attention to something because it's going to be very important later. If we look at a reciprocating compressor, we had a motor driving a crankshaft, moving some connecting rods and pistons, right? Inside of our cylinder walls. Had a maximum RPM, typically about 3,600 RPMs. A lot of them were down lower. So 1,000 to 3,600 RPMs is all you could get out of a reciprocating compressor. Now, when we started moving into scroll compressors, which are very rugged compressors, they have a higher RPM operating range. So typically we can get 1,600 all the way up to 5,800 RPMs, especially if we put an inverter motor inside of that thing. And then we started getting into motors that had more efficient capabilities to them. So we started getting into our ECM constant torque motors, right? Which had pre-programmed ramp profiles. So we'd have maybe 5 different speeds, different fan taps. We didn't have a modulating to them. We had a few out there, but most of them were just those pre-programmed constant torque. If we needed multiple speeds on our outdoor motor, we might put a 2-speed ECM style motor on that thing. A lot of expansion valves getting utilized. And then as we progressed, we took the PSC motor out of our compressor. We replaced that PSC motor with an ECM. And there were a couple different types of ECM motors we used in the compressor. We had our ECM constant torque. So that constant torque is going to be a multi-speed, right? We have constant voltage going in, and we have different frequencies to operate on those. So just like we had our ECM constant torque that had maybe 5 different fan speed taps, our constant torque motor that we would use in that first generation of compressor, inverter style compressor, we could have had maybe 5 different speeds it can change between, pre-programmed, right? Got a lot of efficiency. And even if this was like a 2-stage unit, we could get all the way up to 18 SEER with these in a 2-stage. Now the 2-stage was still just a single speed motor. We didn't change the speed of that 2-stage. Most of the time we just took a hot gas solenoid and we bypassed some of the discharge gas right back into the suction. We reduced the capacity on that. So single speed on those PSC drives. What has happened in the last decade and has really developed in these last 3 to 5 years is our complete variable capacity systems. Now, to do that, we have a few things that we need to upgrade to get the maximum capacity out of it. One of the things that we're doing is we're using a lot more of our rotary compressors. So the rotary compressor, that thing can scoot. If we look at the rotary compressor, we can go all the way from like 1,000 RPMs all the way up to 7,000 RPMs. That's a lot of opportunity to change the speed of the compressor. Now, if we add in variable speed motors like our true variable speed indoor fan motors, true variable speed outdoor fan motors, and then we start modulating the flow of refrigerant using like an electronic expansion valve, man, now we have some capabilities. So in these rotary compressors, we can go all the way down to 10% capacity up to 100% capacity. And if we look at the RPM ranges on these motors, they're getting so high now, we can overdrive our compressors. So we have things like boost mode and hyper mode where we're adding significant increases of RPMs onto the motor past its design point. Anyone ever heard of that? Got quite a few people out there in the audience, and I hope I'm not diving too deep into this because this is a really interesting perspective on how we're producing heat in these ultra low temperatures. And if you don't understand the principles, you're not going to understand the design, and you're consequently probably not going to be able to teach it very effectively. So this is where we have been moving. This is where we can get our high heat capabilities out of that. So when we look at all of these new generations of what we're going to call cold climate heat pumps, what is a cold climate heat pump? Well, it really doesn't have a specific heating range or specific operating condition. And I hope that we resolve that going forward, because right now it's all over the place. So when you're looking at heat pumps, they can have temperature ranges in a variety of different angles. Any questions up on this point? Because I don't want to overload anybody.
We do have some questions here, Clifton.
Sure. What we got, Howard?
I've got a lot of them, but we could take them little by little.
Yeah,
Do all heat pumps continue running no matter how cold it gets outside?
Good point. So that's where this comes into play. When we're talking about inverter-driven heat pumps, they are not all created equal. Some of them will actually shut off at 5 degrees Fahrenheit. Some of them will shut off at 0. Some will shut off at -5, -10, -22. It depends on the design of the manufacturer. And we're going to look at some of these tables here in a second so you can see exactly where those are, so you can start comparing different products.
So, Clifton, if my heat pump shuts off at 5 degrees, what are some of my options? Are you going to go into that too?
So that's the biggest complaint that we see, particularly from homeowners that are buying heat pumps and doing their own installations, which I highly, highly do not encourage people to do. So when we look at heat pumps, and if we don't know what the rating is and what its capability is, we could be purchasing a heat pump that shuts off at 5 degrees, and if there's no backup for that, yeah, you're absolutely out of heat at that point. So it's crucial to understand the capability of the heat pumps when we're looking at our selections. So let's dive right into system performance. I love this. I have spent so much time diving into equipment performance, comparing different products so that I know exactly how much heat these things can produce in different ranges. Now, we're going to try to stay away from brands as much as possible, but we are going to use the data for each one of these so that we can compare them very closely to see what they do. So this particular one, this happens to be one of my favorite products on the market. So this is a residential inverter. This is a unit that fits many applications. It fits on gas-fired, so dual fuel systems, works with air handler, there's modular blowers. It has an electronic expansion valve on the indoor unit. Very, very popular piece of equipment. Now, if you open up your installation manual, and surely everyone's reading their installation manuals for every job, right? We never heard that before, have we, Howard?
Knee pads.
I actually did a video one time on uses for installation manuals other than reading. Anyhow, try not getting down these rabbit holes too far. So in our installation manuals, and if you look at the design of installation manuals, most manufacturers will put your cooling capabilities and the heating capabilities about 3/4 the way through the installation manual. Now, there are a couple of manufacturers that are very stingy with their extended heating data, and they don't release that in the installation manual. You have to be a registered dealer to log into their portals and get that information. So I struggle with that, because if I'm looking at equipment, I want to know everything right up front. So it takes a little bit to find it sometimes, but it is there. So this is how we did it in the past. We went to the installation manual, we went 3/4 to the installation manual, open it up, we found the extended heating data tables, and it gives us everything that we need to know about this piece of equipment. So this particular one, we design all of our heat pump systems around that 47 degree ambient outdoor temperature. So that's why that is highlighted in blue right out of this manual. And if we look at this system, we have a couple of things that we can determine really quick. The COP is super important to understand with all heat pumps. Howard, have you ever heard the term COP?
Yes, sir.
A lot of people hear it and don't know exactly what that is. So our COP is our coefficient of performance. And simply stated, it is the watts of output versus the watts of input. So now we're going to be talking about heat output. Now, if we're talking about like electric resistance heating, backup heat, right? Resistance heaters. We would consider electric resistance heaters to be about 100% efficient. I won't go down that rabbit hole in a minute either. We're not exactly there, but a lot of times we'll say electric heat's 100% efficient. That means for every watt of electricity, we can produce a watt of heat. And so that 1 watt is actually equal to about 3.412 BTUs of heat energy. So if I look at these charts, I can tell exactly how much heat I can produce and how much energy it's going to take to produce that heat. So in this particular chart, I look at 47 degrees ambient. I know that I can produce 34,600 BTUs, and I can do it with a COP of 3.0, which means I am 3 times more efficient than an electric resistance heating or baseboard heating or any type of resistance heating. So our modern heat pumps are very effective at producing heat and even at lower temperatures. If we look at the lower temperature range on this one, this unit actually goes down to -10. And this is where it's important to read these installation manuals to know how low of an operating condition we can produce with that particular piece of equipment. So this one at -10 is still producing 13,800 BTUs per hour, and it's doing it with a coefficient of performance of 1.52. That means it's 52% more efficient than electric resistant heat at -10. So when we're talking about efficiency, when we're looking at balance points on systems, if I can continue to keep up with my heat load, I'm absolutely going to run that sucker down to -10 because I'm doing it 52% more efficient than I would with an electric resistance heat. So that is what is in installation manuals. Now, when we were talking earlier about ways to compare different products, we haven't really had a lot of that in the HVAC industry, have we? Well, now that we're moving into this electrification movement, into this cold climate heat pump transition, where we have areas now that, if you don't know, we're actually we're banning the installation of gas connections on new construction. I mean, how many times have you heard that recently, Howard?
I'm in a city that's already established that.
Exactly. And a lot of people aren't aware of that it is a growing trend in America for that degasification and electrification movement. So it depends on the utilities in your area. And so now we're looking at our options going, man, I want a good cold climate heat pump, but I've got a ducted system. There are no options out there for me. Oh yeah, absolutely there are. And we even have third-party companies that are becoming that comparative tool for us. Now, I will show you the one that I believe everyone in the HVAC industry needs to take a look at to have an understanding of how to compare pieces of heat pump technology. So, NEEP. Anyone out there heard of NEEP? I'll give it just a second in case anybody chimes in on this one. I had not heard of NEEP until we started having our discussions with the Department of Energy in the last couple of months. So NEEP is the Northeast Energy Efficiency Partnerships, and it is a variety of different organizations that are assisting in creating the largest database of cold climate technology for our industry to use. And this is open sourced information. It can be used by anybody. Even if I'm a homeowner looking at different products, trying to figure out what can work in my own application, this is a tool that is available. So for us, it is a very important tool because of the amount of technology that is used in the database. So here's how we start. If we were wanting to find the performance of some equipment, I can enter in the temperature ranges that I'm looking for. I can enter how much heat at 47 degrees, how much heat that I want at 5 degrees Fahrenheit, and if I have a particular brand that I like, I can go straight to that, or I can leave it open. I can select ducted, I can select ductless, whatever I'm working on. So it's just a good combination tool. Now, when we get inside of that tool, what we're going to find is that we have a better heating data chart than what we have with a lot of our AHRI ratings. So in our AHRI ratings, a lot of times we're only going down to 17 degrees Fahrenheit on our heating scales, right? Doesn't tell us exactly what's in those lower temperatures. So NEEP has been spending a lot of time adding all these tables so that we can do very quick comparison, or at least research on how much heat a piece of equipment can put out in cooling and in heating mode. Now, here's where we start seeing our differences, and this is why we're going to spend quite a bit of time today talking about how these things are different and why our pieces of equipment are different in their heating capabilities. If we look at this chart, this is the exact same piece of equipment that we looked at first. That piece of equipment that was actually rated down to -10, and this is where I say there are some discrepancies, so this is a tool. This is not your solution for finding out how much heat can be produced by a heat pump. It's a tool. It gets us in the idea so we can compare, particularly at like 5 degrees, how much heat some different pieces of equipment can put out. But I have to go back to my installation manuals and verify exactly how much heat it has and what is the lowest temperature it will operate. So this particular one, there was that 34,600 at 47 and 19,700 at 5 degrees. That's a pretty significant amount of heat that can be produced in an hour off from a heat pump at 5 degrees. Here is that exact same piece of equipment. If I would have went over to my AHRI looking for my certified rating for that, and as you can see in this particular table, there is no data for this right now. And I think we're going to see that over the next few months as a lot of our organizations are trying to catch up with SEER 2 changes. If you haven't been affected by CO2 changes, you're probably going to see some at some point. Here's one of them. That particular piece of equipment we were looking at had a different model number last year, so it has been recertified for CO2, and so the data isn't in the AHRI table for that yet. That's where we go back to our installation manual. Okay, so say we're looking at our installation manual. Let's go back there again for a second, right? We know there was that rating that was in the tables for NEEP. Here is another piece of equipment coming off from NEEP that I want us to look at how things have changed, because we're going to come back to this at the end, because some technology has changed in our industry that will make you rethink how we size heating and air conditioning products. If you look at this particular one, now remember, all of these, everything that we are reviewing right now, are 3-ton heat pumps that are connected to ducted air handler systems. So that particular one was a 3-ton air conditioner, had rated at 39,400 BTUs of cooling at 95, but look at the heating capability of this thing. That's 59,000 BTUs. What kind of a tonnage would that be if that was in air conditioning mode, Howard? 12,000 BTUs per ton?
Yeah, you're making me do math, but yes.
That's a 5-ton if it was in an air conditioning mode, but it's not. It's producing that in its heating mode, not in cooling mode. And I want everyone to ponder on that for a minute, because that is a big discussion here towards the end. A 3-ton unit producing a little over 3 ton of cooling, but about 5 ton of heating at 47 degrees. How do you do that? That doesn't even hardly make sense, does it? Well, let's look at some of these other products in that same 3-ton range. So this is another heat pump, ducted, centralized heat pump, that has the capability of going all the way down to minus 22. That's why I say that if you use a tool like this NEEP database, you're also going to want to use your installation manuals or your product data to verify, because this particular one does show us. In this NEEP database, this one shows us this particular piece of equipment will operate down to minus 22 Fahrenheit, and in that process, it will produce 18,800 BTUs per hour of heat. That's a lot of heat. And when you look at the scale, it's actually pretty consistent with 3. It's actually more consistent with the 2-ton unit, because this particular one had a 2-ton air handler on it. So the options have really expanded on what we can do with our cold climate heat pump technologies. So this kind of goes back to that previous question, Howard. Do all heat pumps run below the rated point? Do they shut off? And they do shut off at different temperatures. And it's so important to know what that range is, because some are at 5, some are at 0, some are at minus 5, some are at minus 22. So let's look at this. Let's take data. So I've taken 14 different products. I've taken a variety of different manufacturers, and I've taken on some of them a couple different models. So we can look at the true heating capability of some of these ducted inverter cold climate heat pumps. So what are we seeing? I've got 3 different charts, so we can look at it differently in case you have a preference on what kind of chart you like to look at. But let's look at the very first one. Brand A, 17 SEER heat pump, right? That 17 SEER heat pump is the same one we looked at in our first chart. That's the one that goes down to minus 10 and has 14,000 BTUs of heat at minus 10. If we look right next door, now that is a horizontal ducted system. If we look right next door at that 20 SEER, that is a traditional vertical discharge heat pump, the kind of heat pumps we're used to seeing. But it is an inverter, and it will go down to minus 10, and it also produces 14,000 BTUs at minus 10. So if we start walking our way across, we'll see we're going to go into another brand. That particular brand, they're 18 SEER. Now, a lot of these SEER ratings were from 2022, so some of this is going to change in 2023 as our equipment is being recertified. May or may not, depends on where it landed in that chart. So if we look at that 18 SEER in that third row, that thing is producing a lot of heat at 0, but it doesn't go below 0. And that was an 18 SEER piece of equipment. And if we go to the same brand right next to it, yeah, their 22 SEER produces more heat. The downfall of that particular piece of equipment, 22 SEER piece of equipment, we can all imagine what the price is on that, right? It only goes down to 0 itself. So it's not designed with the cold climate, high capacity operating condition. We move into the 15 SEER that's air in brand C. That one shuts off at 5. That one was a horizontal discharge. And then the 18 SEER next to it, man, that thing can crank out the heat at 5, but it doesn't go below it. Where it really starts getting interesting is as we move down that chart, we will see some pieces of equipment that are producing higher heat capabilities at low temperatures, aren't we? Now, when we look at that chart, though, the first 3/4 of that chart are what I consider legacy brands of equipment. Brands that you know very regularly, that have progressed a long time, and they've changed some of the components that they're putting in their heat pumps. They've increased the efficiency of the heat pumps by changing, whereas the ones on the far right-hand side, and I'm not going to add any brands in here, but some of you could probably guess what some of those pieces of equipment on the right are. They are companies that are moving into the industry. Some of them we are not as familiar with because they haven't been here in the States as long, but they've been in other countries over time. And they operate 100% on the full variable philosophy. So variable speed compressor, variable speed indoor fan motor, variable speed outdoor motor, electronic expansion valve, pressure transducers, temperature thermistors. And when we look at the heat capability of those, we look at that very last one, Howard. That is a 22 SEER piece of equipment on an air handler with ductwork, and it can produce 21,000 BTUs per hour at -20. I can't think of any place in the country where that wouldn't be a good fit. That's a significant amount of heat.
Not any place I'd want to live.
No, absolutely not. Most of the time, hopefully, we're going to be in that zero. Look at that. At zero, that thing's producing 32,000 BTUs at zero. Here's where things get hairy. Look at the BTU capability of that thing. That's that one that we looked at earlier on that NEEP chart. At 47 degrees Fahrenheit. That thing can produce 57,000 BTUs of heat at 47 degrees. How do we do that? How is that a 3-ton heat pump? Any thoughts on that? I gotta take a little break for a second, see if anyone has any ideas, because that one makes you think for a second. How are we getting that much heat out of a heat pump at 47 degrees, at -20, and how is it only a 3-ton? Any ideas?
I doubt it.
Yeah, absolutely. I'm going to show you these other charts in case you want to look at it from a different perspective. So this is using the same data, just looking through, going, okay, we got brand A that's getting us down to -10. It's got a pretty decent amount of heat in each one of the ranges. We can see that blue, that dark blue, that's at 47 degrees. So a lot of our heat pumps start out pretty similar. It's just the technology that changes as we go along that creates the higher heat capability at lower ambient temperatures. So there's really only a few of them that operate down in that -20 range. We got at least one legacy brand, and then we have a couple other of these newer brands. But we can do that amount of heat. Here's a different way to look at it. But this lets you see that some of those pieces of equipment are producing a lot more than what we would traditionally call 3-ton. For an outdoor piece of equipment. So if we look at that one, that brand F 20 SEER, that thing's producing 59,000 BTUs. 59,000 at 47 degrees. And the last one on there is producing 57,000. Back up, and one of those legacy brands is producing 44,000. So a lot more heat than what we would expect out of a 3-ton piece of equipment. So is that consistent with what our manufacturers are telling us? And it absolutely is. And if you have never read your extended heating data charts, here's what it looks like, and here's how we read it to verify these. If we look at this particular brand, if anybody knows those model numbers, this is a common manufacturer. This one is ready to go down to -3. At -3 with a 70-degree indoor bulb. Now, mind you, all of these data points that I've been gathering were at a 70-degree indoor dry bulb with airflow. Kind of depends on what the manufacturer says. So this particular one is saying at 70 degrees indoor at -3, it produces around 21,000 BTUs. That's still a pretty good amount of heat, right? If we look at this other one, we're going to see that at -3, it also can do around 22,000 BTUs. That's a 25 SEER. If we look at this manufacturer, now this manufacturer only takes you down to 5 degrees. This is a traditional outdoor unit working. This one actually works with an expansion valve. Can produce 21,000 BTUs, but it takes more airflow. So some of our pieces of equipment can move a lot of heat. We know that we can move more air, we can move more heat. So we have to set the blowers up to be able to handle the airflow properly. Now, this is where we see these higher heat capabilities. So there's 32,000 BTUs, but now I've got to move a lot of air to do that. Whereas some of the manufacturers, you can move the BTUs with a lower fan speed. Some of this technology requires a fairly high CFM. So at 5 degrees, this particular unit needs to move 1,270 CFM to be able to get our 32,000 BTUs on that 70-degree dry bulb. So the importance of looking at how to compare equipment is to understand that they are not all created equal. There are things going on in this equipment that is different from one manufacturer to the other, and reading your data tables and understanding how those data tables work is really what it comes down to. Because this particular brand, this is a different one. If we look at it, instead of having points, it has a window. But that window tells us the same data, how much heat it can produce at each temperature. But as it opens up wide, this is showing us how much heat it can produce as that inverter is ramping up and down. Because we may not have a need for its total heat capability. We might be able to slow that thing down and produce a little bit less heat if our demand is less. That's kind of a cool idea, right? Well, what about the cooling side on some of those things that produced all of these BTUs? How are we doing that? If we look at this one again, just take a second now. If we look at the cooling capability, this is registered as a 3-ton 20 SEER unit. Its cooling capability at design temperature of 95 degrees Fahrenheit is 39,400 BTUs. And that's pretty respectable for a 3-ton unit. That's got quite a bit of capability. Look at its heating at 47 degrees. It's 59,000 BTUs. How do we do that? This is the point where a lot of people get stuck, is on how to interpret what's going on here. So remember when we were talking about our inverter, when we move into our fully variable speed compressor, and we have the ability to ramp that compressor, especially if it's a rotary that's going from 1,000 all the way up to 7,000 RPMs. Can't I modulate everywhere in between? Can I over-ramp that compressor? That's exactly what we're doing. So this would technically be, if it was running at 100% capacity in cooling, it could have been a 5-ton. But because we have designed it to be a 3-ton unit operating on the proper amount of CFM for a 3-ton air conditioner, that means in cooling mode, our compressor doesn't ramp all the way to 100%. It is limited by our airflow. In a lot of our new technology, we are measuring the pressure on our motor and we're calculating that into static pressure so that our, like communicating thermostats, we're actually calculating how much static pressure is on our ductwork so that we can limit the amount of airflow in our system so that we are not getting too much static on our ductwork. Remember, that's the whole reason we redid our SEER ratings, was because of our poor ductwork here in the United States. So I limit my capacity on my outdoor unit so that I'm only producing a 3-ton unit for cooling. But as I start needing that necessity for heating, I allow the compressor to continue ramping up and continue ramping up to the point that I can produce all the way up to, in this particular one, 59,000 BTUs of heat at 47 degrees. So this is what has changed our perception of heat capacities in our cold climate inverters. In the past, we've always looked at our cooling capacity. Our outdoor unit was just based on how much cooling we needed, right? That's all we ever looked at our outdoor unit, is how much cooling capacity do I need, and that's what that size of that outdoor unit's going to be. As we've started looking into our cold climate technology and our inverters, we have looked at it from a different perspective. At least some manufacturers have. Some manufacturers have looked at it as, I'm probably going to need more heating capability than I'm going to need cooling capability. So if I allow my outdoor unit to ramp to higher RPMs to be able to produce more BTUs to get the heat that we need, then I can just simply limit the running of that compressor in cooling mode. That's an interesting shift than what we've seen in the past. Any questions popping up out of that, Howard, or anyone in the audience? Anyone got any thoughts on that particularly? Because that's a big shift in the way we've looked at equipment in the past.
We've got a lot of questions that are coming in. It's just if you'd like me to throw a few of them at you.
Absolutely. Let's take a break for a second. Let people ponder on that one because
and
it
like
changes
to say,
the way we
many
look at
people
it.
may not realize. Some of you are watching this on the HVAC Learning Network. Others might be on Facebook, YouTube, LinkedIn. So we get a lot of questions on different platforms. I'm going to look at a few from a few different places.
Yeah, absolutely.
That's okay. Clifton, the NEEP website seems like a great tool to help consumers understand various products. What is the URL? Where would I find that?
So to get to that one, let me go back to that real quick. So just Google Northeast Energy Efficiency Partnerships, and that will take you straight to the NEEP site. And you'll want to bookmark it because this is some really good information.
It's a great tool.
Yeah, handy tool. But it is just a tool. Now remember, as we've seen in some of these, it might not be completely filled out with all of the data that the manufacturer has for that piece of equipment. It'll get you into that range. It'll tell you what kind of heating it'll do at 5, because I've seen data for 5 degrees for every piece of equipment that I've looked at. But some of those pieces of equipment didn't have the complete data below 5 degrees. And that's where you need to verify that in your installation manual or in your operating manual for that piece of equipment.
It's a tool to help you. Nothing replaces doing research on a manufacturer's
Just
website. Another
tool. You know, I do a lot of woodworking, and we always say measure twice and cut once. It's the same thing when we're selecting equipment. Whether we're selecting equipment for our classrooms, whether we're selecting equipment for a sales lineup, or whether we're selecting equipment for a homeowner, or whether we are a homeowner. Understanding the capability of equipment is crucial, but is never a substitute for all of the test data that comes from the manufacturer.
So, Clifton, are there different qualities of components for inverters?
So here's an interesting one to dive into. If we go back in, and I think I've only got one other slide past that one, so I want to go to something real quick, and I want everyone to think about this. When we are talking about the changes in products over time, wouldn't you think that we have already left pistons and capillary tube systems? I mean, that was our original equipment that we were putting into our air conditioning heat pumps, right? Very inefficient, didn't have the capability of flexing refrigerant flow. Here's a crazy one. So in the process of learning the heat pumps, in diving into heat pumps, tearing them apart, cutting things open, learning how we operate heat pumps, I've ordered a couple different ones, and I have one on my shelf right here in the shop. I have a unit that I purchased off from a popular online website. So basically, do-it-yourself kind of a unit. So I wanted to see exactly how it was constructed. Is it using Sandwall components? Is it using Emerson components? Is it using LG components? Is it using the primary manufacturers of components that we see in our unitary and in most of our residential products? You know, the interesting thing about it, so I ordered one. It was just a 15 SEER heat pump, but it is an inverter heat pump. It has a DC indoor motor. It has a DC outdoor motor. It didn't have an electronic expansion valve. It actually had a capillary tube. Can you believe that? So when it comes down to components, it really does come down to quality manufacturing. Are we going to see inverter systems out there that are inexpensive? Yes. Are we going to see inverter systems that are not truly variable speed on all the components? Yes. Are we going to see inverters that don't have electronic expansion valves, therefore cannot be capable of running at ultra low temperatures? Yes. A lot to interpret, and that's why we need our tools. We need to be able to compare different pieces of equipment to see what the capability is, put some high quality manufacturing to it, and then get the data that proves exactly how those things operate. So that was the whole point of looking at heat pumps as, are heat pumps created equal? No, they're absolutely not. They are all over the board. Now, are we going to spend a lot more money to get the most efficient ones? Yeah, we probably are. But now we have the tools to actually be able to validate how much heat can be produced from these things. And then remember, this is only on the ducted side. If we go back and look at these numbers, let me get over to that screen real quick. Because once I put these numbers together, it really just solidified the importance of understanding our technology. Where are you? Yeah. On that's showing us on ducted systems that we can have a 3-ton inverter heat pump on an air handler with ductwork producing 21,000 BTUs of heat at minus 20 degrees. So for the naysayers that say that we don't have heat pumps that are capable of cold climate capabilities, here it is. They're out there. You just may not have been subjected to them yet. You may not have encountered those yet. So you definitely want to dive into it and see, what the opportunities are. I see one of the messages that came through here. Will this be available on YouTube? Absolutely. We want you to come back to YouTube and share and learn a little bit more about the technology. Because remember, we started doing this so that we can keep up to date with the changes of the industry. And these are the changes of the industry. And these are the tools that we are going to see. And hopefully we're going to see even more tools like this one going forward so that we can compare different products and different heating capabilities.
So, Mr. Beck, is a multi-stage inverter really a true inverter?
Well, so let's think about that. So when we were looking at the different parts that go into a system, and we talked about the evolution of heat pumps, and along the way, about the middle way, we went from permanent split capacitor motors in our compressors to ECM-style motors. And the earlier generations of those were multi-speed ECM. So we could have a multi-speed ECM indoor fan motor. We could have a multi-speed ECM outdoor fan motor. Neither one of them true variable speed. They just had different selectable speeds that could be changed from the indoor fan board and from the defrost outdoor board. And then we took the PSC motor out of the compressor, kept our pump inside of the compressor. It took out the PSC, permanent split capacitor motor, and put in a multi-speed ECM. So, is it an inverter? Well, it is able to vary the speed of the compressor. So technically, absolutely, it is an inverter, and it is an electronically commutated motor that is driving the vapor pump. So we end up with, and you'll see these units out there that are like a 5-speed inverter. It truly is a 5-speed compressor. It is an ECM-driven motor, so it's a 3-phase motor with some kind of a controller, an inverter board, that is modulating the speed of that pump. So it's not a true variable capacity. It might have 20%, 30, 50, 70, and 100% capacities, and it just steps up and down between the capacities when it needs to. But it's not the full variable speed that goes from 10% to 100%. And remember, it's not even 100%. A lot of these boost modes are taking us to 115%, 125%, 140% of the rated capacity of that system because we're driving those RPMs up so high. So most of those that overdrive so much are probably not going to be a scroll compressor. Those scroll compressors are typically limited to around 5,800 RPMs. And then those rotary compressors will get us all the way up into 7,000 RPMs. That little thing's going to be screaming. That's going to be a shock to the installer or the service tech when they go out to work on this thing and they walk up to it and it's producing heat and it's just at 7,000 RPMs. That's a different sound when you're used to hearing a compressor chugging along at, say, 2,800 RPMs. So a significant change in the sound and the performance based on the components internally.
Do all inverter heat pumps use electronic expansion valves?
No, they don't. So it kind of comes back into the same philosophy. Electronic expansion valves are the highest performing. Absolutely. Are they required to hit some of those higher SEER units? No, they're not. So we have a lot of equipment out there that will operate in fairly low ambient conditions on a good, what we typically call inverter-tuned thermostatic expansion valve, which means it has the capability of opening and closing in a pretty significant range, more than we would have with a single or 2-stage compressor. So there are a lot of thermostatic expansion valve controlled inverters in the field. I have even seen some that have variable speed indoor motors, variable speed outdoor motors, variable speed compressor, and thermostatic expansion valves. So we have a combination. That's why we say they're not all created equal. They are created by the manufacturer for a specific market and a specific range. So what is that range? That's where you have to do the research to find it.
So Clifton,
yes,
we need drain pan heaters in cold climates.
Oh boy, there's a good one. One thing that gets overlooked by a lot of installers, I would say many of our true cold climate ones, the ones that are going down into the very negative temperatures, are going to require an additional drain pan heater. Because if I'm operating at -20, if my system's capable of running at -20, and I go through a defrost at -20, that condensate coming off from my coil is going to try to freeze very quickly. And we have seen that. We actually seen that this year. We've seen pieces of equipment that were not properly installed for their climate zone, so capable of producing ultra-low temperatures, but were required in the installation manuals for an additional drain pan heater that was not installed, and therefore that piece of equipment was having failures because it was ice damming in very low temperatures. And what's that going to do for the product name and for the product quality? It's going to ruin that. So we have to make sure that we look in our manuals to validate if our piece of equipment requires a drain heater in those lower temperatures. A lot of them do. Good question.
So this one I'm going to ask, even though you've covered it, says, is it true some places require heat pumps for new construction? We get this question every day.
We do.
From a lot of places you wouldn't expect to be talking about heat pumps. Alaska, Montana, New York. I'll let you field that.
No, you're right on it. If you want to roll with it, roll with it. We're even seeing it in the UK, where we're now setting legislation for 2025 that all new heat sources are going to be non-gas for new construction. So there's a lot of legislation happening around the world for cold climate heat pumps, for electrification. And we've seen areas, well, you've seen it yourself, that are requiring alternative to gas heat sources on new constructions. Cities, counties, and we have seen a couple states that are now pushing for that as well.
Clifton, are there resources, funds, incentives for homeowners to convert to cold climate heat pumps?
So there are starting to. Good question. So we had some discussions a couple weeks ago with our friends over at PNNL, Pacific Northwest National Laboratories. It's a laboratory division that works with Department of Energy initiatives. And so we have seen that there are going to be some significant changes. We're hoping those are going to be launched here in 2023. There are rumors that some of that may not get pushed through legislation and delivered until early into 24. That's yet to see. But they are on the plate for delivery of incentives to install cold climate heat pump technologies. So absolutely, there could be significant funds coming here in the near future. There are some right now, but it's based on your local areas, and some electrical utilities are providing some as well.
Where can I get more information on cold climate heat pumps? How do I stay up to date?
I would say the best thing to do is to show up for our Did You Know show. So head on over to a variety of different resources. You can go to escogroup.org. You can also learn a lot more about our National HVACR Education Conference that's coming up, but go to www.escogroup.org. You will see our webcast on there. You could go to our LinkedIn on HVAC Excellence or ESCO Institute. The primary one is probably our YouTube channel, ESCO Institute-HVAC Excellence, and subscribe to that and turn on notifications. And that way, when we have our guest on and when we bring up these topics, we have the resources right there for you, and you have the opportunity to join in and ask questions and be a part of this initiative to train our industry as a whole. Good stuff.
You know, to me, the one thing I'll say is change is everywhere. It's not just our industry. If people look around, mRNA vaccines, we start talking about CRISPR technology for gene editing. Anyone who doesn't pay attention to the news doesn't realize how quickly technology is changing. HVAC is just part of it. And I think that those who really take the time to educate themselves, they're going to be on the forefront. They instead of complaining, they're going to capitalize and their businesses are going to grow.
Absolutely.
From learning about this.
When we look at the equipment itself, a lot of this equipment comes with onboard diagnostic tools. And we had discussions last week with Fieldpiece on using smart diagnostic tools to gather and retrieve and log data. So the technology has changed to the point where if you are willing to invest in it, it really has a lot of benefits on time saving and analysis, and really creates a much more efficient service condition. Well, cool. A lot of great stuff. So glad everyone joined us today. Didn't get past the 1 hour mark, but that's a lot of things to think about. And we know that there are topics that are going to make us sit and think, wow, okay, I hadn't really thought about that. But this is one that we've gotten a lot of attention on. We've had a lot of people want to know what is happening in the industry. What can we prepare for? One of the questions came in, sounds like load calculations before servicing. Absolutely. We're going to be spending a lot more time talking about load calculations, and we'll dive into that here in the near future as well, and how to proper select equipment, which is kind of what this falls into. So great stuff today, everyone. We appreciate you joining us, and make sure to keep yourself educated. Get to some of the conferences, learn about the things in the industry, and don't be bashful. Get on back here next week, and we will see you then on Did You Know? The ESCO HVAC Show. Thank you for joining Did You Know? The ESCO HVAC Show, brought to you by the ESCO Institute and HVAC Excellence. Our mission is to bring the top educators of the industry here for you in a live, unique experience so that you can join us from multiple social platforms, all with the opportunity to ask questions, to be involved, and to learn about the things that are changing in our industry as they are changing. Subscribe to our YouTube channel to get notifications when we go live every week. Are you an educator looking for resources to be the best that you can be? Man, you're in the right place. And we invite you to come join us at the National HVACR Education Conference, where we bring all of these guests and many more, along with manufacturers and different organizations of the trade, so that we can all be in one place at one time and gather this information to make us better together. How do you learn more? Go to escogroup.org, select HVAC Excellence, and then the conference. I look forward to seeing you again next week on Did You Know? The ESCO HVAC Show.